Welcome. In this video, we're going to be determining whether variables are directly proportional. From our previous lesson, we discovered that if I have two variables, x and y, and I want to, the condition for proportionality is if I divide corresponding values of y and x, they should always be equal to a constant. A constant being a number or a figure. Now let's take an example of a table of values, and we are going to be determining whether variables are directly proportional from first a table of values. So for example, if these are my values of x and y, and I'm required to determine whether x and y, in this case it's actually x and p, whether x and p are directly proportional, what I need to do is to get corresponding values of x and p. So I'll do p out of x. My first value is 15 out of 1, sorry. My second value is 30 out of 2. My third value is 45 out of 3. And all of these values are actually equal to 15, which is a constant. Now, because p over x is a constant, then p is directly proportional to x. Now, what if I have a graph? Now, we are going to try and understand this from a graph. Remember that the condition for proportionality should still stand, but this time we are interpreting this from a graph. So let me drag my graph over here, and we want to determine whether y is proportional to t. From this graph, you can see that that's our y, that's our t, and that's our graph. I'm going to take points for A, because each point gives me a certain value for x and a certain value for y. I need to look at my scale. When I look at my scale from here to here, those are 20 units for y. So I need to know what each small unit has. So that's 1, 2, 3, 4, 5. So it means that each small square over here is actually 20 out of 5, which is a 4. So now, when I look at point A, this is 20 and two small squares. So that's 20, 24, and 28. So on my point A, for my point A, my t is at 28, and then, sorry, my y is at 28, and my t is a 1. Let me rewrite this so that it's very clear. From my point A, my y, let me start with t, because we start with x values when we are writing coordinates. My t is a 1, whereas my y is a 28. Then if I go to my point B, my t is a 2, whereas my y, so this is a 40, again this is 44, 48. And then my point C, my t is a 3, whereas my y is this is a 60, 64, 68. Okay, so for these 3 points, I'm going to do y out of t. Okay, so my y out of t, the first for point A, is a 28 out of 1, which is a 28. For my second, for my point B, my y out of t is a 48 divided by 2, which is a 24. Okay, now 24 is not equal to 28. This means that my y out of t is not a constant. My y out of t is not a constant, meaning that those are not directly proportional. Y is not directly proportional to t. Why? Because I've not fulfilled the condition for direct proportionality. Let's look at another example which involves a graph. Let me get my graph from over here and drag it. Okay, so from my graph, let me use it from over here. From my graph, we can see we have a graph of y against t. So still using the same condition, we have to get coordinates for each point. My preference is for you to get exact points, like this plotted point. When I look at my scale, from here to there it's 50, and there are 10 small squares, which means that each small square is 5. So I have this point. Let me start with this point. No, let me start with this one because it has a number. Let me call this point A. So my point A has a t value, and the t value is 1, while the y value is so this is 50, 55, 60, because each small square is 5. And let me get another value. When t is 2, I have y value, so this is 100, this is 110, that's 120. My y value is 120. Let me call this point B. And let me get another point C. Now, let me use these two. Let me use these two, because that's where my graph ends. So, I'm going to try and investigate the condition of proportionality. So I'll do my y out of t from point A is going to be 60 over 1, which is a 60. And again, my y out of t from point B is going to be 120 over 2, which is a 60. Now, because these two satisfy that condition, it means that my y out of t is a constant. So y is directly proportional to t. So once again, our aim was for us to determine whether variables are directly proportional. We can do that from a table of values by getting dividing corresponding values to prove that they satisfy the condition of one variable divided by the other should be a constant. Then if it's from a graph, we have to extract points from a graph and divide those corresponding points. If the division is not a constant, then the variables are not directly proportional, like in this case. And then if they are equal to a constant, then those variables are directly proportional. One other way you can tell this we talked about last time, your graph has to go through the origin if two variables are directly proportional. And like you can see, this graph does not go through the origin being 0, 0. It doesn't go through the origin, so you can tell straight away from looking at the graph that the variables are not directly proportional.